So please, Srijit, check that link.
Uh, uh, just tell me one thing. Some of them say that there is an audio noise. So is that you can hear any noise from in Google Meet from my side?
Yeah, there is a small buzzing, but now it is not so prevalent. But at times it becomes prevalent.
Okay, that may be because that whoever is broadcasting the YouTube.
Yeah,
Okay,
yeah.
so
Okay,
maybe.
yeah. Okay, okay. Snehashish, I have forwarded you the link of today's stream. Okay.
Yeah, that. Yeah. So it's already streaming. Should we start or just wait for some time to join others?
Just wait for 5 more minutes. Start at 6:15. Okay.
Yeah, yeah, yeah. Okay,
Sharp
okay,
at 6:15.
okay.
এই গল্পটা ভালো ছিল, জানিস? হ্যাঁ, ছেলেদের কথাগুলো কেমন? বসে বসে শহর থেকে গ্রাম সবাই। এই বল, কিছু খারাপ কোথায় গেল? আইনি কোথায়? এই চা দিবি দাদা?
Good evening, all. How you all guys are doing? At least we can chat until uh, everyone joins. Um, have you gone through the sections we have done so far?
ভালো করে বৃষ্টি হয়নি কেন?
Am I audible to all of you guys? Those who are watching it on YouTube? Okay. You guys have gone through the concepts or the codings of logistic regression and linear regression, or have you gone through any other resources if you have done so? Or if you have any questions, maybe we can discuss the questions today in the uh, after we discuss finish off the um, logistic regression because we left something some part of it yesterday. So if you have some questions, I will be gladly taking those questions after completing the entire uh, logistic regression part. Meanwhile, you guys are actually getting something, right? I mean, you are getting what the coding is trying to interpret. Okay, Krishan, don't worry. Linear regression, if you have any doubts, I will give a quick review of all the models we will be taking. We will have all the models a quick refresher after we finish the modeling. Okay, so linear regression, logistic regression, and today we will learn KNN, so K nearest neighbor. So after finishing off all these models, I will give a quick review of the along with the codes so that you can understand what are the building blocks. Maybe while I'm explaining the code, you may get too involved in the code and overlook the process. So there are similar process to build any model. Okay, so if you just remember those process and just use some of the statistical tools, you can make any models. And again, every model is like uh, building the model is not a big deal, okay, because every model has their syntaxes built in scikit-learn. So if you have seen here in logistic regression or linear regression, it's max to max a 3 line code to make the model and fit the model and train the model. But the main pain is to make the data good enough to feed into the model. Okay. Um, so we will be discussing all the steps we have done so far after we just finish off the building model. Okay, so bear with me. Uh, I guess it's 6:16, so we should start by now. What do you say? We should start or wait a bit more?
No, no, start. You can start, Manjush.
Okay, okay. So with that said, let's start where we left off. So if you just a brief of yesterday's class. So first we imported the libraries. Okay. Then after importing the libraries, we imported the data. That is my Titanic training data. So there are two data: Titanic train and Titanic test. So if you see here, these are the two data: Titanic train.csv, Titanic test.csv. These are readily available from Kaggle. Okay. So if you have Kaggle, if you go to Kaggle and search Titanic test, Titanic dataset, you will have two datasets. So we have downloaded it, we have uploaded into our Jupyter homepage. Then we called the data pd.psv. This is the data how it looks like using train.head. So we put it into train. The name of our dataset is train. So these are the dataset. These are the columns. Okay. So then we saw is there any null value or empty cell missing value. Okay. So these are the result of if you pass is null, it will return a boolean output. Okay. So to see this boolean output a little bit more easily, we plot it using heat map. So the same syntax we passed into heat map. Okay, the same syntax, and then some. These are the syntaxes or arguments to make it visible more friendly. The, that I y tick levels. So the tick levels in y axis, I just put it false so that we don't need those. C bar is equals to 4, so I don't need many colors here. Okay, and color map is very this. Okay, so these are just to visualize it more easily. If you don't pass those these arguments, then also it will plot. Okay. Then we went on to see some other stuff. The first I made the color background style white grid. So if you see here, this is a white background and this is the grid. Okay, so I made this style to make it more visible. uh, then we see the our target data set, that is our whether a person given the data is survived or not. So these are the data sets, survived and not survived. Okay, survived means one, not survived means zero. So lot many people died in the accident, as we know. uh, then we want to see those who survived or didn't survive. How many of them are male or female? So we plotted the survived column in context of sex. So hue here is sex. If you want to see in context of any other thing, you can plot it. Like if you change it to P class, passenger class. So first class passenger died more, or second class passenger. So if I just pass on uh, P class. I guess that is the name, P class. Yes. If I pass on P class, okay. Oh, sorry. I need to run all the cells again. So just run, run, run. Now, if I just run, and now if I run it, you see, these are the if person those who are not survived, most of them are from class 3 or third class passengers. Okay, those who survived are more or less of the same. Okay, most of them are first class. Okay, so first class passengers survived more, and uh, died less number of first class passengers did not survive or died. Okay, so in context of any parameter, you can see who survived, who didn't. Then we moved on to the age. We want to see what are the distribution of age who boarded on those who boarded on Titanic. Okay, so we split it into 30 bins, so there are 30 groups which the entire age range is divided. So these are the 30 groups, and we can see the distribution of number of people with respective ages. So most number of people are in the age of 22 to 25, 70 number of people, right, more than 70. So like this, here you see, for the example, we dropped the any value. So if there is a missing value in this column, we dropped it to see what are the distribution firstly. Okay, then we show this that using your pandas inbuilt plotting functionality, we can plot it. So we didn't use SNS here, we use Seaborn to plot this distribution. Here we didn't use anything, just pandas. We plotted it. Then we saw the information, the fair distribution. What are the fair distribution? We saw it. We use cufflinks, a new library for interactive plotting. Okay, so if you want to explore more about cufflinks, you can always go and check their official documentation. Okay, so in cufflinks we can do a lot of things. So we can zoom out, zoom in. Okay, you can double click to zoom back. If you hover over your mouse pointer, it will give you the exact number data. So you can do a lot of things with coupling. Okay. Then we plotted the heat map of missing value. What are the missing values? Which column misses which value? Okay. So these are the missing values. Then we see as age has less number of missing value, Kevin has lot more missing values. So we tried to resolve this issue. Then we take passenger class and age to plot a box plot. Why? To replace this age missing value. So if there is a passenger class of first class, so it is expected to have a higher age, because the money you need to pay for a first class ticket is takes you more time in life. So that likewise, as we can see it here also in box plot, the first class passenger, the age of the first class passenger is nearly 40 years, whereas the second class passenger have nearly less than 30 years of age, and third class passenger is between 20 to 25, right? So using this information, passenger class, we build a function. If the passenger class is from first class, the returned age or the missing value is using 38 years of age. If the passenger is from second class, it will be imputed as 29 years of age, and third class is 25 years of age. Okay. Then we applied this missing age function. This is the missing age function, and we apply the dot apply function like we used lambda function before. Now we created our own function and applied it. Okay, where we applied it, age and passenger class. So we take two columns from the main data train. We applied the missing age function. Okay, and the applied output is override on the age column. So that's how we get our all the age columns filled. So if we just then plot this age column, let me just okay. Meanwhile, when I'm talking you through, let me just run all this cell. Okay, otherwise, train info, train, um, the map. The heat map is done. Then we do the box plot. The box plot we ran. Then we made a function and we ran it on the page. Then we plotted the modified. Then we visualize the modified train data set. Okay. Now if we plot the value, SNS, the age column is filled in. If the imputation is done, so there is no missing value in age. Then what we did, there is so much of missing value in Kevin. So what we did, we dropped the column. So train dot and the column name. So we dropped the column, right? Then after dropping the column, if we run this, we don't have the column name called Kevin, right? After dropping the column Kevin, we just you see there are single or two rows in embark which are missing. So we just drop these rows. Okay, to drop the row, we just did train drop in it. So any missing value now will be dropped. And so as we know there is no missing value in age, we drop the entire Kevin with missing values. Now we don't have only this missing value. So we don't try to find out which rows. We just simply dropped rows with not with missing values. So if we run this, then what we had, if I run this and we just after that, if I just plot it, this value after doing the data cleaning. So my data is probably now cleaned. So if I do this, now you see there is no missing data. So entire data is filled. Okay. Now when the data is filled, then what we did uh, uh, categorical to numerical transformation. Why we did this? Because the categorical value cannot be processed using a model. Okay, the model only understands a numerical input. So we have categorical input here, sex, name, and embark. These three are the categorical inputs having strings or characters. So what we did for sex, there are two categorical values, male or female. So we did male and female. So if you see, if male is 1, female will be zeros, female is 1, male will be 0. So that is a 0 1 combination. So we don't need both the column, so we just dropped the first column. Okay, so if you do that and put it into a particular variable, so we have a variable called sex, which is a male sex. For 1, if it is 1, then that means it is a male. If it is 0, that is a female. So we only need one column to identify whether it is a male or female. Now, same will do with embark. So embark has three distinguished characters, S, C, and Q. Okay, the S, C, and Q. Q is not visible here, but it is there. If you see the unique, if you want to see how what is the syntax? The column name dot unique. Okay, so you will find the or dot count value counts. It will give you the number of counts for S, for C, and any other unique character or unique elements. Sorry. Mm, so we did that and we found there are three categories. For that, we just made it a numerical categories using get dummies. Okay, and we put it in a variable called embark. And here also we drop the first column, because if I know the status of other two column or other two city, we can find out whether it is a third city or not. For here, let's say it is not Q, not 0, sorry, not Q, not S. That means it is definitely the C. Okay, the C city. Queensburg, Southampton, and C for something. Cherbourg or something like that. So if both are 0, that means it is a Cherbourg. Okay. Now, after getting this done, what we need to do? Now we need to incorporate this newly introduced values into our data set. So we did. Okay, let's just run it. Okay, df, that is not df. Okay, it is my right now. Then I put it. I concatenated our new two columns, that is sex and embark, into the train. So train, sex, and embark, we concatenated it column wise. So for column wise, it is axis 1, and then we ran it. Embark is not defined. Okay, I didn't run it. Embark, train. Now you see, uh, mail, Q and S. So embark has two columns, Q and S. It is added. The sex had one column, male. It is added. Now, if you see, we have embarked and sex, which essentially means this essentially represented by these three columns. So we don't need these values now. The categorical inputs, embark and sex, and also we don't need this thing, name. That is also a categorical. We will be simply discarding these three columns. Okay, and you can do some processing to find out any useful information from name column, like we said last day, Mr., Mrs., Doctor. How many of them has this initials? We can find it out and use this. Okay, but for the timing we are dropping this column. Okay, so sex, embarked, name, and ticket also dropped. Okay, so we don't need ticket because it also carries information like A, B, C, and this thing. We need to process it. So for the time being, we are dropping this column, and it is not also very useful, because what is the ticket number? Maybe if we do feature engineering, maybe that became handy. But for the time being, we are also dropping this column also. Okay, so name, sex, ticket, embarked, and passenger ID is also not like very useful. You see, this is just the number, serial number, right? Passenger ID 1, 2, 3, 4. It goes continues like that. So we don't need this also. So what I will do, I will just add another column name passenger ID. I guess that is the name. Yeah. So if I just run it, and if I just run it now, see my training data is all numerical. Okay, so this is the data which is ideal for training. Now I have made my data ideal for training. Okay, my data is ready. Now what I will do, I will build our model. So that is where we left off. Okay, so let's do the model building. So I will I will create my training data and level data, features and levels. So this is my level, the survive, and these are my features from P class to S, right? These are my features. So I will take X as my data features. So to do that, I will simply train dot drop the column survived. And how I will drop it? I will drop it column wise. So axis is equals to 1. Okay, if I do this, I will get an X without this column, and I will get the level Y is equals to just simply calling the survived column. So this is my X and Y, that is my features and levels. So if I ran it, this is my XY created. Now I will import the libraries. So from sklearn dot cross validation import train test split. Okay, I run it. What happened? Oh, from sklearn dot cross validation. Why it is not importing? Did I? train test split, cross validation. Post. What happened? Why it is not showing? Train test split. The model selection. It changed its model selection. Okay, it's not cross validation. Actually, the cross validation was previously the model where train test split situated. They moved it from cross validation to model selection. Okay, that's why the confusion stays. Now, after importing train test split, we will just create our training dataset and testing dataset. One thing to mention here, you can use the entire dataset Titanic train for training, and then you can import and process the test dataset and use it for testing. But as we need to go through all the processing, so I am saving a bit time for us. You can always go ahead and train the model with entire training dataset. Okay, that is Titanic train. So let's just build the model. X train, y x test, y train, comma y test is equals to train test split, and inside that I will pass on my these two variables, that is my features and levels. So this is my x and y, x comma y. Okay, and then I will pass a test size is equals to, let's say, 30% of my data will be used as testing, and then I will state a random statement. Random state is equals to 32. Okay, let's just run it. So my trace train split is done. Now let me just create some more space. Okay. So my test train split is done. Now I need to import the model itself. So from sklearn dot linear model import logistic regression. So if you tab it, you will see logistic regression CV. So we will simply use logistic regression. Okay. So you can always press tab to auto complete your syntaxes. Okay, there is no harm doing that. In case of Jupyter Notebook, if you are using some other ID, there must be some other short hotkeys to find out the related keywords, okay, or syntaxes. So this is, I have imported this. So let's import it. Our model is imported. Now I need to create an instance. I need to create an instance. It's a linear regression, logistic regression. Let's logist. Let's give the name logistic regression as logist. Okay, so logist is my logistic logistic. Why it is not showing the tabs? That is my, oh, it just changed to code to something else. So logist is equals to my logistic regression instance. Now I will apply fit to my training data. So I have created the instance. I will fit the instance to my uh, training data set. So I will write logist dot fit. I will pass my X train and Y train to training the data. Okay, and let's just run it.
এটা ছিল এয়ার ডায়মন্ড, এটা ছিল এয়ার ডায়মন্ড।
What happened?
না ওর এখন মরে যাওয়ার মতো
আচ্ছা
এখন
এখনো
যা
কিন্তু
শুনছে।
এখন চান্স দেয় না, এই জন্য লিখেছে না ও যে বলিউডে ও এখন তামিল তামিল তেলুগুতে এখনো দিয়ে যাচ্ছে ও সাউথ
ও বলিউডে
ইন্ডাস্ট্রিতে।
যেগুলো করে খুব জঘন্য শুট দেয়, খুবই জঘন্য।
কোথায় রে জঘন্য? লাস্ট কোথায় এটা?
লাস্ট অরিজিতের গানটা কি ছিল, কি চক্র,
ঠিক আছে, ওটা যে লিরিক্স লিখেছে সে বাদে লিখেছে,
শুটটা কি ছিল বললা।
Let me just.
সব করি না
ওইটা দেখতে
Is
হবে
there any
পুরো
problem with
চ্যাট
that?
এয়ার এমনের সাথে আর মধ্যে দেখ না
Logist dot
দুটোই দেখ তাহলে।
fit. I divide it into X train and Y train.
এয়ার
Yeah,
এমন
X train,
চ্যাট
Y
প্রথমেই দেখ ওটা
train.
ইউজ কি থাকে আমি দিস ওটা সার্চ করো।
What?
ইন্ডিয়ার
This is a warning.
অডিবল
Okay.
বা
I,
মিউজিক্যাল।
yeah, this is a warning. So our model is ready. Let's see. Prediction is. Let's do prediction as spread. Uh, Logist. It is actually saying to use a large amount of data because our data is really essentially small. Okay, so either we do in number of iterations or we just scale up our data. So that is not a thing to worry about right now because we are not dealing with real-time data. This is just a exemplary data. Okay, because it hardly has 700 columns, I guess, 700 rows. So maybe that is why this warning is available, mm, showing up. So let's just find out what are the predictions. Okay, so predict is spread
আগে একদমই জানতো না ইংলিশ,
logist dot
সত্যি বলছি, কারণ ও
predict,
এত ভালো শিখে রে, কারণ ফ্লুয়েন্সি বলে।
and I will pass on my X test. X test is not defined. Okay, that is a small x.
এরকম করে রেখেছি রে বাবা।
Our prediction is ready. Now I want to see how good is my model. How good is my model? So for the
দুবারকে করলো তখন তো ছোটই করছিল, আবার এটাকে
what
বড়
you
করে
say,
দিচ্ছে।
the evaluation, we need to import some matrices because it is a classification problem. So I will import the classification matrix, which is confusion matrix, and other parameters like precision and recall and sensitivity and stuff like that. So to do that, what I will do, from sklearn dot matrix import classification. So let's
কিছু
import
ক্রিম দিয়েছে, জেল দিয়েছে, একটা ফেস ওয়াশ দিয়েছে, ফেস ওয়াশটা
আর তুই যেটা হিমালয়টা এনেছিস ওটা কি হবে?
ওটা মাফ করে নেবে।
classification report. Okay,
এটা কি হবে?
একটা যে জেল দিয়েছে,
classification
যায় আসে না।
ফাটিয়ে মারবো। এই দেখ কি বাজে দেখ
report.
চেকমার্কগুলো হয়েছে দেখ, পুরো কালো
Oh,
হয়ে গেছে
scikit learn,
দেখ।
man. I'm spelling too much
এই
today.
দেখ
Classification report and confusion matrix.
বললাম ওঠাবারে,
এটা আমি কবে জানতাম কেন হয়েছিল দেখলাম ও আজকে
Confusion
নাকি আমার একটু
যে
বলে
জেলটা
উদ্ধার
দিয়েছে
করেছে।
ওই জেলটা মাখবি এর জন্য হয়েছে।
আমি সাডেনলি
matrix.
লম্বা হয়েছি না একটা
Okay,
জিনিস তো।
so from that, so I have imported these two factors. Now I just pass on my predicted output and my actual output to compare this and do the confusion matrix and classification reports. Okay, so let's just do that. Let's say print classification report
যারা লাইভে আছে তার জন্য
and pass my the actual
জানি।
output, that is my y test, and my predicted output, that is spread. Okay, and also print
আমি কোথাও অন করে রাখি।
confusion matrix and pass this same parameter y test and the prediction. Let's just run this. This is my prediction. Our accuracy, overall accuracy is somewhat 0.80. That means 80% accurate. Our model is okay. So this is the model output. So out of this classes, the survived or not survived, 183 and 75 are correctly classified, and around uh, 29 and 25, these two are the erroneous character. This is my type 1 error, this is my type 2 error, right? So it is nearly about 54 elements are misclassified, whereas the rest of are correctly classified. So our model is accurate enough. That is not the best model, but it is good enough, it is considerable. The accuracy is 80%. Okay, and don't worry about the macro average and weighted average. Just see these functions: precision, recall, f1 sort, and the accuracy. Okay, so out of 267 elements, only 54 elements are misclassified and rest are correctly classified. Okay, so this is all about my logistic regression. Okay, I encourage you to try all the training data again and test it with the test data. Do the processing of the test data, just clean the missing values and the categorical values and all this stuff, the thing we done with train data. And you can do some feature engineering also, you can grab the name and find out what important thing you can find out from the name. You can use the ticket also to find out if there is anything useful. Okay, so you do feature engineering, you see the correlations, okay, between the functions, tickets, and survive. If there is a useful correlation, then you use that. Okay, I encourage you to explore more with the exploratory data analysis. Okay, then again use the logistic regression and see what difference it makes. Okay, so I guess logistic regression, this is the I would wrap this up, this model, logistic regression, and then I will move on to the next model, that is our k nearest neighbor. Okay, but before doing that, let me just grab some water. Okay, meanwhile you just go through the processes. Okay, and I will be back in 2 minutes. Just 2 minutes of break. Okay, let me just grab some water.
মোটামুটি এই টাইমে তোর হবেই দেখ বলা দেখ ও ও বললে পালানি পালানি পালা 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 বল্টু বল্টু আমি পাগলানি বলেছি হ্যাঁ তাই তো কাদানি না পালানি হ্যাঁ কাদানি পালানি 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 পালা বললে কাদা হয়, পাদা বললে কালা হয়। কালা 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 এই এত নেটটা কোথায় হচ্ছে রে? এক্ষুনি তো হলো, এত 3 দিনের পেট ভরেনি হয়, আরো চাই আসলে কি জলটা মাখছো যাবে পাবে না জল ঠিক আছে। দেখ গুঁড়ো দেখ গুঁড়ো দেখ উস্তাদ গোলাম এই নাম দিতে গেলে লোকে একটা নাম করে রে অনেকেরই নাম ধরতে গেলে নাম ধরে গুরু এখানে যে থাকে এরও নাম ধরতে গেলে অনেকে নাম বলে নামটা বল এখানে গান শেখায় প্লিজ আরে ও গান শেখা ও তো গুরু নাকি ও আর অমিত চাওয়ান একই একই না অমিত চাওয়ান
Okay, I'm back. Thank you for holding up.
এ নুসকান
Um, so now, without any further delay, let's jump into our next model. That is our K nearest neighbor, right? So before starting the coding, we will just see a brief introduction about what is K nearest neighbor, how it works, the
না 10
uh,
মিনিট না না লক
background
গান
theory
তুই
about it.
বাজাতে পারছিস না আমি
Although
আমার
I
তুই কি
will
করছিস
use
করছিস
very
অফ করছিস
limited theory,
যা
if you
এই
want to
তুই
dig
কাজ
deep,
করিস
I will give you the
করিস
reference
তো না
also.
তুই তো করিস না জানা
Okay, so let me just share my screen,
এই জন্য বলে
other screen.
হয়ে গেল
Okay, so today, now we will be talking about KNN, right? Let me just- K and nearest K nearest neighbor. Okay, so K nearest neighbor is probably one of the simplest uh, classification model. Okay, one of the simplest model, machine learning model. And how it works, it works looking at the neighbors, what neighbors are doing, it will do the same. Okay, depending on what neighbor, it listens to all, or at least one who are the closest. Okay, like it works like our society, we listen to all the especially the closest one, our parents, our relatives, and do accordingly. So K nearest neighbor is just like the society. Okay, so how it works, let me give you an example. But before moving along, I would give you the
তাহলে KNN
reference first.
intelligent
So this is
consequence
the
machine
same book,
learning এর KNN এটা বুঝে নে
Introduction to Statistical.
এভাবে
পাবে বসে থাকলে কি করে পাবো উঠে দাঁড়াও তবে তো পাবে
সবাই তো
আশ্চর্য বসে
তুই
থাকলে
কাজ
পাই না
Learn
করছিস
আমি এই বসলাম আরে বসে থাকলে পাবে এটা কি করবো একটু হাঁটো পাবে তো
by
তবে
Gareth James, and you can find it in chapter 4.
কেন ডুবি সব মশলা টশলা মাখিয়ে আমি আলাদা
Okay, so this is my reference.
লেমনটা ওর থালাটার মধ্যে হ্যাঁ হ্যাঁ ওই থালাটার মধ্যে মাখিয়ে নিয়ে তাহলে সে একটু দিতেই হবে
If you want to dig deep into statistical learning, K nearest neighbor, you can always go to this reference. Okay, so let me just give you an example so it will be better for you to understand how it works. Let's say we have two classes. Okay, so we have a class male and female, and I have two features. Let's say weight and height. Okay, using these two features, I would like to classify whether the person is male or female. So I should have some test data. The test data says like this: if
আরে এই দেশলাইটা অনেক দিনের রে ওই জন্য জ্যাম পড়ে পড়েই
and
হয়ে গেছে যদি বৃষ্টি নামে না আমার কাপড়টা একটু তুলে নিচ্ছে যদিও নামেনি মেঘ ডাকছে আমার মনে হয় অন্য কোথাও একটা করছে
let's say this is my test data, where
ওইরকম এঁকে এঁকে বোঝায় বলুন
this green box is
এরকম গ্রাফিক্স
male
গুলো করে করে বোঝায়
and this this is my female.
তার মানে ও যেখানে পড়াচ্ছে
Okay,
সেখানে
so this is my training data set. Now if this is my training data set, what KNN does, it actually at the time of training, it actually does not train. So please remember, this is an important aspect of KNN. It do not train the model. So what it does, it records, it keep a record of the model. Okay, it store all the model. Training means here is storing all training data point. Okay, so when I am giving these inputs, the model will remember each and every points. Okay, each and every data point. If this is the weight, this is the height, and this is the whatever you say, this is the class. For this is the weight, this is the height, this is the weight. Okay, so it does not remember class. It essentially remember the values. Okay, height and weight, and it maps to the class automatically. Okay, so when we are given the y train. Okay, so the x train is this, y train is male or female. Now when there is a new entry, there is a new point we are giving to the model for prediction. Let's say this is our point. What it will do, our KNN model, it will it will look around at this point, and it will draw a, it will create the distance plot, distance measurement. So it will create, it will calculate the distance from every other point of training value to this point. Okay, so if this is my x, so x is my, this is my x. It will try to see what are the distance for from every other point of the training data set, and then it will sort the data set in increasing order. So one is from 0.02 distance, one is from 0.1, then 1, then 2.5, likewise in this increasing order. Then when we are passing, like take 5 closest values, so it will take top 5 closest values. Then it will see out of this top 5 how many are male, how many are female. If 3 are male, 2 are female, this point the KNN will say then this is also male. If 2 are male, 3 are female, then it will say this is female. So this is how it works. So it creates a surrounded circle of close nearest neighbors and see what the neighbors are. So if I just see here, this is 1 2 3 3 female and 1 2 2 male, so it will be classified as female. Okay, if I just put it in here, let's say it's just let's just create some values. These are my values. Okay, and these were mine. Now if I just create a new point here and draw the circle around it. Okay, so what it will see, it is a 3, it is taking 3 neighbors, 1 2 3, and out of these 3 it is seeing that 2 of them are male and 1 is female. Okay, now if I just uh, enlarge the circle or apply more neighbors to decide what will be the class of this new point, it may change. Okay, like here 1 2 3 4 5 is female, and 1 2 3 4 5 6 7, oh, it's still male. Okay, but it may change depending on the number of neighbors. So number of neighbors decided by k here. So k is the number of neighbors we consider, so k nearest neighbors. Okay, so this is how it works. It's pretty simple, pretty easy to apply also. Okay, so k will affect the value, affect the output or the prediction. So how we will decide what is the best k? So we need to search it. There is no straightforward answer to it. We need to vary the k and see how the result is changing, and then we will find a elbow method. I will explain it when we were discussing. Okay, let's explain it right here. So when we will be increasing or decreasing, the change of error or accuracy will increase or decrease. It looks something like this. Okay, uh, from 1 to, if we increase the neighbor size, it changes like this. If this is my uh, error rate, this is my error rate. We will see in our code also, this is my error rate and this is my uh, number of k. It changes like this. Ideally, I mean, let me draw it a bit clearly. If this is my error, this is by number of k. Okay, error means the miss classification. Okay, if I increase the number of k, it actually not that curvy. It actually is something like this. Okay, the error goes down as we increase the k. Okay, and there are some point after which the uh, minimization of error is very less as compared to the increment of k. So if I increase the k, the error may decrease, but at a cost of computation. So we decide this point as the optimal point for the model. So this is how we decide the number of k. We will see it once we code, so that it will be more clear to you. Okay, just remember this as this curve looks like an elbow. This is called elbow method. Elbow method to find out best k. Okay, so this is the entire KNN. Okay, how this KNN works. Now let's jump into our coding. And if you want to know more about KNN, you can always go to this uh, book and read it. Or otherwise, you can always go to Stack Overflow or other area to read a blog about KNN. Towards Data Science is a very good blog. I highly suggest Towards Data Science. The blogs are very good here. You can read the blogs here also. Okay, these are some useful references. And Stack Overflow. Okay, so you can always find your answer here. Kaggle is there also. There are a lot of internet source, digital source out there where you can always refer to your problem. Okay, so having said that, let's just switch my screen and do some coding to make a KNN model. Okay, so just hold on a second while I am changing my screen. Okay. Okay, so as we know, let's use our Jupyter notebook to create. Okay, let's first save this one. Okay, about Jupyter notebook, if you don't know, you can save it or download it as your Python file. Here is .py. Let me just show you that also. If you save it, you can rename it here. Save as like for this is my logistic regression. Okay, we can save it, and you can download it as .ipnyb. That is my Python notebook file. It can open on Jupyter notebook like this. You can add comments and markdown, and if you want just the executable format, in executable format you can download it as .py. So this is how you can download on in several formats, also other formats, PDF and other stuff. Okay, so this is how you download and upload it. Okay, having said that, let's just close logistic regression for now, and let's create a new tab, a new file to create our KNN. Okay, so first of all, just let's just rename it as KNN, model design. Okay, so this is my model. uh, First, we will do the basic stuff. I hope you all are habituated now with the importing stuff. So let's import all the stuffs. Pandas, then import NumPy. Then I will be importing the visualizations. Let's just import all the. Oh, 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 oh. Okay, so I've imported my libraries. Now I will use a data called classified data. Okay, so uh, let me just show you. This is my classified data. Okay, so this data is like there is no prior information to the data. What is the data, what is the background of the data. We will just use an unknown data to categorize it. Okay, and the output class is also unknown. So many a time you will face this where while you are working, that the context of the data or the domain knowledge about the data is not known to you. Okay, so in that case also you have to perform your part as a data scientist. Okay, and many of a time the company says you to do some machine learning but don't want to disclose the actual meaning of the data, so they will modify the data, change the column names, change the target variable names, so that you don't understand what the data is about. Okay, so but anyways you need to do that. Okay, so for that let's import the data and see how it looks like. Let's say df equals to pd dot read csv, and import the data as classified data. Classified data. Okay, and I will take index is equals to 0. Okay, let's just leave it. Just see how the data looks like. Df dot head. Okay, this is my data. Okay, so I have a column named 0. So that is what I was trying to say, index is equals to 0. Uh, can I do this like this? Index equals to 0th column. Doesn't use index. we will just drop it afterwards. Okay. So for now, let's just use it. Um, okay. Now, what I will do, I will do some normalization. Okay, as you can see, these data are very we don't know the context of what is WTT, PTI, EQW, and these all are the encoded variables or features that we don't have any idea what it says, and we don't know how what is the range of this data. It can range from minus infinity to plus infinity because we don't know. Okay, and the target class is also doesn't reveal anything more than zeros and ones. So what do? We just do one thing. We first normalize the data. So whatever the range of the data is or the coming input is, it will uh, transform to transform into 0 to 1 or minus 1 to plus 1. Okay, this is the concept of normalization or standardization. Excuse me. Okay, so let's do that part. So for that we will import from sklearn preprocessing, import standard scalar. Okay, so this is a standardization function. Standardization function, if you remember from our terminology term, it is it uses the mean and standard deviation to get the data standardized within a fixed range, right? So we will use this standard scalar to standardize our data. So how we will do that? We will just use it as we use our model. So we will create a instant, like let's say std standardization is equals to our standard scalar. We pass this, then we will fit std dot, we will perform fit with our actual uh, data, this data. But before fitting it, as you see, this is my target class. We don't want to fit this class. Okay, this is only zeros and ones. Okay, so I will want to standardize the features. These are my features. Okay, so we will standardize all the features but the target class. So what we will do? We will do df dot drop, that is my target class, and how it will be dropped as column. It will be dropped as column. Okay, so let's do this. And after fit, you need to perform the transform. Okay, so it fits the data. Now it knows the data. Now it has to transform the data into the desired format. So how we will do that? So let's say the transform feature, so the standardized feature or std feature, standard feature, another line, standard feature is equals to std dot transform. std std dot transform our data df, from where also we will drop it. We will drop our target class and we will drop it axis wise, right? Sorry, column wise. So axis is equals to 1. If I run it, our data is standardized. Okay, so our df dot head. Let's see our df how it looks like. You see all the data. Uh, 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 uh. Okay, we need to over std feature. We have std feature as our new converted feature, right? So let's uh, don't have object. Oh, so std feature is saved as numpy array. So let's transform it as a data frame. So let's take std feature is equals to pd dot data frame and our, let's name it something else. Std feature feet is equals to, we will transform this into the data frame std feature. Okay, and the columns will be, what will be the column names? The columns will be the same as the data frame columns from the original, but not the last one. So I will exclude the last one. All but not last one up until the second last one. So let's just run it. Now just see what is std feet dot head. Std, man, std. A lot of typo error is happening today. Now you see we have our uh, column standardized. Okay, these are my column. So this unnamed column is not of our concern. So we will just drop this std feet dot drop name 0 0. So let me just see what is wrong with this data. Just a second, guys. Let me just check what. Let me just check. Let me just Okay, let me just do one thing. Just get rid of this column here. Uh, where is this? Let's just do this index. I couldn't find the reason why it is coming so. Okay, so just get rid of this here already. If I do this, okay. Uh, I don't know how this column introduced because it was not in the original file classified data. Um, but if I just put index column equals to 0, it actually what it did, it made the unnamed column where what we had, this one unnamed column, as the index. Okay, so this is how we can convert a column into index also. So essentially we shouldn't have this column, but I don't know how this appeared. But instead of troubleshooting, let's just get rid of it for the time being and move on. So right now I do this. Okay, drop views. Okay, so now we have our data set normalized or standardized. Okay, now what we will do, this is actually pretty much structured data. We don't need to do many processing here. So let's just jump right into it and see how we can design the model. Okay, so to do that, uh, what we will do, we will just take the data and give it a name like x and y as my feature and level. So what will be my x? X is will be directly this thing, this entire thing, because we don't have a target. So this is my standard fit. This is my x. You can use direct standard fit, but just for the sake of convention, I'm using x and y. So this is my x, and y. What will be my y? Y will be my the target class column. So df target class. Okay, so this is my target class column. This is my target y. This is my training feature x. Now let's do the train test split. Okay, so let's just run this first. So for train test split, we will import from sklearn dot uh, from sklearn dot model selection uh, import train test split. Okay, then what we will do, we will create the same process. The process is repeated again and again. X train, Y train. Okay, X train, X test, Y train, Y test, and we will pass our XY is equals to train test split, and pass my X and Y variable as feature and level. And then we will pass some, what will be my test size. So my test size will be 30%. Okay, and my random state is equals to 42. Okay, so this is my test trend split. Once we are done with test trend split, we will now call the model itself. So from sklearn dot neighbors. SKLEA of sklearn dot neighbors, we will call k neighbors classifier. Okay, KNN import k neighbor classifier. Okay, so this is my classifier model. After calling the model, we will just create an instance like KNN is equals to uh, this is my model k neighbor classifier, and will pass our input arguments as if how many neighbors we want to have to classify a new data. So let's start with k is equals to 1, then we will increase our neighbors and see how the performance uh, varies. Okay, so n neighbors is equals to 1. Okay, then I have created my instance with my parameters. Now I will fit this instance KNN dot fit uh, KNN dot fit about where which on which data we will be fitting X train and Y train, X train, Y train. Okay, this is my fit, and after fitting, what we will do? We do prediction. So let's just fit this. Okay, now let's just predict. So pred is equals to which on which data we will be predicting the X test. So KNN dot predict X test. Okay, our prediction is done and it is loaded on pred variable. Now we will compare and see our confusion matrix and classification report. To do that, we will import those two modules, those two functions from sklearn dot matrices. Okay, import classification report and confusion matrix. Okay, these two we need to import, and then we will be printing our result. So what will be our result? One is our confusion matrix, and will pass our actual data and predicted data. So y test is my actual levels and pred is my predicted levels. Okay, also we will be printing our entire classification report. So classification report, and again we will pass our y test and prediction. Okay, so this is our classification result. So as you can see, our model is pretty much accurate. It is giving 94% accuracy even with single neighbor. Okay, we have taken a single neighbor to classify it, and it is giving a very good result. But now we will just see what is the, so if it is a 94% or 0.94 accuracy it has, that means it has a error of like say 0.0607 of error, 7% of error, or 0.0607 error. Now we want to decrease the error, right? We want to decrease the error even more. Let's do by increasing the neighbors and see what how it affects our model. Okay, to do that, to try separate models. One way you can do, you can just change it here again and again and see how it affecting, or you can simply create a loop and train it in a loop. So let's do that in a loop. So let's say error rate I create an empty list. I will create an empty list. So for I in range 1 comma 20. Okay, so I will start from 1, k equals to 1, and go up to k equals to 20. You can increase the number, but it will take time. So I don't know how much time it will take now. For example, okay, let's let it run. Okay, so KNN is equals to k nearest neighbors classifier, and we pass in neighbors is equals to I. Okay, so I will be increasing every time for every loop, and what I will do KNN dot fit. Now I will fit the model with X train and Y train. Okay, then what I will do, I will make a prediction. Pred underscore I is equals to KNN dot predict test, then error rate dot append. Just bear with me, I will explain all the code. Okay, just a minute, let me just type the code. Okay, I will take the mean of the spread I, which is not equals to the Y test. Okay, uh, so just hold on. Let me just run it. Test is not defined. It will take some time, guys, because it is again and again it is training. So okay, it is done. It didn't take much time. So I changed the um, range here up to 40. Okay, let's just now, as we have error rate, what we have done is here we change the rate range. So range is from k equals to 1 to 40. For each k I am training and fitting and predicting, and after the prediction is done, I am just appending the output, the prediction output, as a mean value. Okay, so I am taking the mean and not taking the Y test, only the prediction, which is not equals to Y test, and appending it into error rate. This is my, I created an empty list here, and this 40 values will be appended in the error rate. Now I will be plotting this. So let's just plot it. uh, let's just plot it like this. uh, plc.plot. I'm using simply matplotlib. So plc.plot. Let's just range. What will be the first x-axis? X-axis is my range 0 to 40. This is my x-axis, and y-axis will be my error rate. Okay, let's just make it more prominent by uh, adding some more arguments of the visualization. Let's just make it color blue. Okay, then the line style is dashed. Okay, uh, um, marker is equals to O. Marker face color is equals to, let's say, red, and marker size equals to 8. Let's just make this plot a bit bigger. Plot dot figure by creating the fixed size window. Fixed size is equals to, let's just make it 12 by 6. Okay, so if I run it, okay, what goes wrong? X and Y must have same first dimension. Okay, what is the range of error? Okay, this is 1 to 40. Range is 1 to 40. I'm sorry. This is how it is looking like. Now you can see the first for k equals to 1, the error rate was 0.6, less than 0.65. For 2, it went up, then went down, then again went down, 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 and then again up, down, up, down. Although the error is in like 6% or 5%, so it is very much good at the beginning also. But you can see if we increase the size, the error eventually comes down. So here, if I draw a line, so this could looks like something like from here it is going down, then up, then again it is just settling down, right, beyond 30. So we will just take this thing. This is my, let's say, mm, 12, I guess, 11, 12, 13, 14, 15. So k equals to 12, giving me a satisfactory result. Okay, so we will just use the same thing as k equals to 12 and see what is the output. So just copy pasting just this thing and make it k equals to 12. Then after that we will do the prediction. Then we will try to see the confusion matrix. This is the total. So you see 1, 2, 3, 4, 5, 6, 5. This is 5 line of code of designing a model. That's it. You see our predict accuracy goes higher at 95%. Previously it was 94%. So 1% of accuracy increased, and we just made it a 12 neighbors. Okay, by increasing k, we made a accuracy increase by 1%. Okay, so this is how it goes up. So this is my this is the case of k nearest neighbor, and this is almost covered. We have done k nearest neighbor training and testing. Uh, Few things about KNN, although it is a very, the pros for KNN is it is very simple, very basic model. Okay, the training is trivial. Okay, uh, works with any number of classes. So if there is thousands of class, it can work with it. Okay, easy to add data. You can add more and more data to it, and so easy to add data means it is less complex to add up data. Okay, it is not good with large data, but it good to it is relatively simple to add data. Having a model trained, you can just add a data because it is essentially not training, it is just storing the data. Okay, so adding data into the model is not a complicated task. Okay, and error parameter, as you can see, only one parameter we have, that is the neighbor k, number of k, and there is another parameter called distance matrix, because how the distance is measured from the new point to other points, training points. This is called distance matrix. If you want to learn about distance matrix in detail and background, you can refer to the book I recommended. Okay, or any other digital platform also. So there's only two parameter to tune, so it is relatively simple to form. Then what is the con? The con is, for a big data set, the prediction cost goes high, very high. Okay, so if you have millions of data for each new data, it will calculate the distance of the point with the millions of the data. So it will take a lot of time. Okay, and to find the k, you need to repeat this calculation again and again. With iterations, you will get the error less and less. So it is not very suggested to have KNN implemented when the data is huge. Okay, and it is not good with high dimensional data. So let's say your data have hundreds and thousands of features. So the distancing hundreds and thousands of features from a new point is a bit more complex, and it may give you adverse result. Okay, and categorical features. Okay, categorical features it is not good with. So these are the cons of KNN. So with that, I guess I have covered KNN pretty much all the basics. And these are the four models. Three models we have discussed: uh, linear model, the logistic regression, logistic regression, and KNN today. So we plan to have naive bias, but I guess we should focus on discussing doubts rather than moving on with another model. So I will stop it here. Okay, my modeling, and I will switch back to Srijit or Archik if there is anyone. So if any one of the viewers have any question, they can ask. Uh, Srijit, is there anyone with any doubt? I would like to clear. So if you can pass the question to me. Could you give us two examples of very basic and advanced applications of machine learning? Yeah, Sunita, the very basic and advanced examples of machine learning, like we see it in everyday lives, like Google Assistants, for example, Siri. These are examples of machine learning which follows the path of natural language processing. Okay, uh, the Google photo, Google image, Google camera. I'm sorry, Google camera. It has a machine learning algorithm which can identify the images or the objects it is seeing through the lens. So it is an example of machine learning. That is a computer vision. It is a problem of computer vision. Self-driving car. Google is trying to implement the reinforcement learning to create self-driving car. It is still very on experimental stage. So these are some of the machine learning applications, and you can create anything right now for machine learning. So weather prediction is more of now going towards machine learning rather than just seeing and analyzing manually. Okay, recommendation. So home said recommendation system, chatbots. Yeah. So these are the examples. Somojit asked if there is a null value, uh, how we will find the index of the null value. Okay, if you have a row of null value, then what you will do, you will just do, let me just write it in the comment. You can find like this simply. Is null, then followed by index and convert it into the list. You find the is null value. Let's say df, a is a column. Okay, so you find is null, you see the index and find it to list. So it can find you the null values. Jishu, you are asking you can implement machine learning algorithm to deep learning. Yes, you can apply machine learning algorithm to deep learning in a way. Sometimes what happens that you have a data, let's say for time series data. Okay, so whatever example we have used till now, these are some already have features. So we know this age, uh, sex, and ticket, or all of the columns. We have those features. But in case we don't have any features, we have a series of data. What you can do, you can create features using machine learning. Okay, and then once you have features created, you can feed that features created from machine learning into your deep learning model. Okay, so you can create a hybrid. Actually or you can do it vice versa, because you don't know how to create. If you don't know any domain knowledge, what you can do, you can apply a deep learning model into a raw data. Okay, then the deep learning model, uh, before the last layer, although a lot of you may don't know, there are layers. The last layer gives the prediction or the classification. Just before the last layer, you can extract the second last layer, which is the features. Now once you have those features, you can apply those features into the machine learning. Okay, which is better, machine learning or deep learning? Entirely that is entirely depends on the application. Okay, uh, in machine learning, you need to have the features beforehand. Okay, you need to you can manage the features, you can convert the features in whatever way you want. Okay, and in case of deep learning, you don't have much control of controlling the features, how the features are being created or generated. It just gives you the output, and you can always tune some of the parameters, but you cannot essentially tune the features that is created in every nodes or every layer. Okay, so depending on what is the application, you can see if you have a data with features and loaded things, and you want to tune at the feature level, you want to see I want this feature to behave like this, that feature to behave like that. Just like we did, we just create 5 new features from one feature. So if you want to do this, then machine learning is the choice. If you have data and you have nothing called feature, you can use that data in deep learning. Okay, but deep learning essentially needs a lot more data than machine learning, generally speaking. Okay, Somojit, can you write the code in the comment section? I just wrote the code, Somojit. This is the code. Let me just write it down again. Yeah, if you have a data called df and there is a column A, you can find is there any null value in A, and you can find the index using dot index, and you can make a list of the index values. Okay. Any other queries? Okay, I guess there is no other queries. So thank you all for attending this webinar. I hope you have got a brief idea, although this within these 4 days we couldn't have covered as much as we wanted, and there were some technical glitches in middle of. Uh, I guess yesterday we had some technical glitches, so there were challenges, but. I guess you have now a basic idea of what machine learning. If you want to have a deep, thorough understanding, I urge you to go through the pandas and numpy and the visualization library first, and then do data exploration. Okay, you take up a data set from Kaggle, you do the data exploration, and after that, once the data is clean and have a good structure or a desirable structure for a model, you try all the models, KNN, logistic regression, uh, for classification, SVM, and all the models. And there are hyperparameters inside the model. You can once you know the basics like what is regularization, what is alpha, all those things, you can tweak those parameters also. Okay, but the main part is the data, data cleaning and EDA, exploratory data analysis. The more you do that, you will be becoming very good machine learning practitioner or data science engineer. Okay, so with that, thank you all. Uh, I hope you take away some of the knowledge from this webinar. Uh, with that, I would like to conclude. And Bridget, uh, are you there? Uh, the session is over. What is the use? Some tight in plotting. Okay, tight. That is not tight layout. Somojit. Tight layout is something to display the image, display the plot in a proper ratio. So if you have lots of X levels or lots of Y levels. So uh, those can overlap with each other. Okay, to manage that plotting and the ratio, plotting ratio, we use tight layout. So it is like plt dot tight underscore layout. Okay, so this is something like that. It will automatically manage all the layouts. Okay, I hope that is clear. Is there any other question? Prithvish, I don't know what is wrong with the importation of Seaborn in Linux. I haven't used Linux environment and Seaborn together, so I cannot essentially say what went wrong. But you can always do one thing. You can just copy the error that is showing and go to your Stack Overflow. Okay, maybe you can find some answer there. Uh, at least some hint of what can went wrong. SNS.cluster map. This code is not running for Devik. Uh, other, that is not first of all ANS. That is SNS. You may have mistyped it here. Uh, so cluster map. You, uh, can you just say me what is the error message you are getting with this? I mean, not just by saying I'm getting an error, just let me know what error you are getting so that I can have an idea because of what this error is showing up. What error did you get? I mean, that is what I need to know. What error did you get? I guess Somujit and Pritish, you don't have the particular error right now with you. But one thing I can do is I will share the solution of those files with you so that you can compare what went wrong with your code. Okay, and you can have a idea because of this uh, because of this which error can occur and the error occur because of what um, mistake. Okay, so both of that you can know. So I will share with my team the solutions and as well as whatever content we have used, the data and the code file. So you can um, practice that. Okay, I will give you the data and the content. So you can run it through on yourself and see if there is an error or not. Okay. Uh, Value error. Uh, Please check the name of your module, the cluster module, the cluster map, SNS cluster map, whether you have spelled it right. Uh, if right, you just go to where you imported your SNS. For Somajit, telling this to you. If you have imported the SNS, you just type in a cell SNS dot and keep a tab. Press a tab and see if cluster map is appearing or not. Okay. So if it is not, then that means cluster map module is itself not present. So you just need to reinstall your SNS CBOT. But that should not be the case. The If you have installed it correctly, the cluster map function should be there. Is there other thing working fine? The SNS library with other functions? Yeah, you can send me. Uh, you can send it to this email. And they then I can get it from there. Let me just give you the send this your screenshot or whatever code error you are getting. You can send to this mail, and I will look into it. Okay. So that means your day month is in your data there is some problem. Okay, maybe your value is not up to at the format. So it is hard to tell me from here, but what I will do, you just send me the mm, problem in that email address. I will communicate with you through this email address. Okay. Archik, are you there? Uh, See, Shomoji, then with this is using this email. You can also contact me. I will be responding to you if you send your problems to this email also. Okay, there won't be any issue. So don't bother much. And if you need something, you can always contact me. There, you can send me a request into LinkedIn. Okay, from there we can have a chat. Okay. For email, this email, I can have your problem through this email also. Okay, so if you wish to connect with me through that, then you can always send a connection to LinkedIn. So,
Okay, so Snehashish, are you done with today's station?
yeah, I guess
Okay,
there
so
is no more questions also, so we
okay,
can conclude it.
okay, so thank you everyone for joining us for this workshop. Thank you, Snehashish, for felicitating this workshop. So, okay, thank you.
Okay. Thank you all. Thank you, Pi Paradox, for organizing this collaborative work. Okay,
Thank you, thank you.
I'm looking forward for such more initiatives.
Yeah, yeah, we'll
Thank
definitely do that.